Duplicating a database. In this nugget, we're going to cover at least 2 exam objectives for the OCP test. We're going to start this discussion by understanding why we would duplicate an Oracle 11g database in the first place. Then we get into the center stage part of this nugget, actually how to perform a database duplication. As we're going to learn, there are 2 main ways to go. One, using existing Oracle 11g database backups. This has been a method supported in Oracle for several versions. And then we have the second method of database duplication. This is called active database duplication and involves our being able to do image file copies from a running Oracle database to our auxiliary or copied instance. I'm going to put an asterisk next to this procedure, and this is actually what we're going to do in our demo, because you should be aware that not only for Oracle, but just about any IT certification exam vendor, they're going to focus their questions principally on new technologies with a given product release. And because the active database duplication feature is new in Oracle 11g, we can expect to see more coverage on this particular method. Let's get started. Now, a core principle of adult education is why am I learning this? And specifically with regard to this nugget, why would an Oracle DBA want to duplicate, or as it's often referred to, clone a database? Well, there's many good reasons. I've enumerated the major ones for you on this whiteboard. First, the issue of restoration. I've made note in the past when I taught you how to do Oracle backups that doing trial restores is extremely important, not only so we're cool with the procedure, and by cool I mean psychologically cool. There's nothing worse than being nervous and rattled when you're having to do a database restore. I want to make sure you're good with restoring, in particular doing a trial restore periodically to verify your backups that they're good, and also, as I said, so that you're comfortable with the procedure. Restoring a database to a different host, maybe from your production side to your development side, is often done in order to give, for instance, your developers current data. You don't want to put your developers or your QA testers on the production live database for a variety of reasons. I mean, that's just common sense. We don't want human error to introduce a problem in the production database. We also want to keep concurrency up as high as possible, and we don't want to add additional locks, waits, and latches to that production database when our QA people and our developers could be perfectly happy working on a clone of that production database. Another really cool reason for duplicating an Oracle database is for testing purposes. I've made reference to QA, or quality assurance testing. Think of some systems admin things like applying patches, application, line of business application upgrades, even testing a new release of Oracle database. You never ever want to do that kind of stuff directly on your production instance. Best way to do it is to clone your production instance on the same hardware, or as close as possible the same hardware, and then run your tests in that safe sandbox. A third reason for duplicating a database is to extract objects for restore. You might have a user who inadvertently drops a table from the production database, or maybe deletes a bunch of rows accidentally. One way among many, flashback is actually a quicker way to do it in most cases, but if you have up-to-date data or relatively up-to-date data in your cloned database, you can certainly run a quick data pump job and pull that or export those rows or that object out of the cloned database and then import it into your production database. So it just gives us another fallback if something goes wrong on the production side. Finally, we have the notion of reporting, or OLAP. OLAP stands for Online Analytical Processing, and generally speaking, in most shops, you have business units, business analysts in particular, who are tasked with mining your data in your database for trends, for forecasting purposes, etc. Again, if you turn those business analysts on the same production database that your customers and other employees are hitting, you're reducing concurrency. Why not clone that production database on a regular basis and then have your business analysts run their reports on that cloned copy? Now, Although we use the same RMAN command, the duplicate command specifically, to do a database clone and create a standby database, there's a fundamental difference between a cloned database and a standby database, and we are not dealing with the standby database in this nugget, but let me just quickly tell you what the distinction is. When we clone a database, we create an exact copy of either the entire database or a subset of it, but once you create the clone, there's no further connection in between the target database and the auxiliary or cloned database. With a standby situation, you SQL Server people in Microsoft land know this as transaction log shipping. You have a nexus or a connection between the target database and the standby database, and periodically we're applying logs from the target to the standby, redo logs, to keep the standby up to date. So you really have a warm copy of that production database. And then the idea is if you have a problem with the target where it goes offline unexpectedly, or even as a change management process you may need to bring it down administratively, we can temporarily bring the clone up for service because it's up to date. It's concurrent with the primary. So that's called standby. And that's beyond the scope of this nugget, but because it's a related term, I wanted to mention it to you. Now, let's talk about some general principles of database duplication. We know why we would want to do it. I think I made a pretty solid business case. Let's look at some of the facts about it. Number one, you have quite a bit of flexibility in terms of how the two variants work. Backup-based duplications versus active database duplications. The biggest difference is that a backup-based database duplication involves either image copies or backup sets needing to be available at the time of duplication. Whereas in an active database duplication, you do not have a requirement of having a backup on hand, and those image copies, the file copies, go from the live production database to the clone. Now, if you're thinking in terms of consistency, good for you, because you're thinking along proper lines. With a backup-based duplication, we can rest assured that recovery is not going to be necessary because we have a solid backup set. Whereas in an active situation, you're by definition going to do an incomplete recovery on the clone side because the database is still running. There are advantages or disadvantages to each approach. Some administrators like the fact that in an active database duplication, we can keep the production database online and working just fine. The biggest downside to active DB duplication, of course, is the load, the system load that's required in terms of CPU and memory utilization on your target server or the primary server, as well as the network traffic. With a backup-based duplication, as long as you're regularly taking backups and you've got them scheduled properly for downtime for at least areas of time periods, I should say, of least user use, then that duplication schema barely hits the production database at all, really. I mean, the production database is only involved during the backup. After that, almost all of your work is done on the clone or the auxiliary side. Another issue you might be thinking of is, what about the database identifier or the DBID? This is the unique number that brands a database and keeps it globally unique from other Oracle databases. If we clone an Oracle 11g database, well, aren't we going to run into problems along this line? You Windows administrators are probably thinking of the security ID and some problems that we used to have many years ago when we would clone operating systems. Well, the good news is, as long as you're using RMAN to do the duplication, RMAN will generate a unique DBID for the auxiliary instance. You don't have to worry about that. Now, if you went about this in a user-managed way, just doing everything manually and not using RMAN for the duplication, then yes, you would have a true clone, and you could definitely run into problems with that DBID. Another issue we're going to address shortly is the issue of file names and file paths. That's definitely one of the potentially time-consuming issues of doing a database duplication. Absolute best-case scenario, if you're doing a data dupe on two different hosts. By the way, you can do a database duplication on the same host or different hosts. The best situation is to have the same directory structure on both machines. That way, the amount of manipulation you have to make to your file paths and your file names is minimal. If you're doing a database duplication on the same host, then you have some issues there right off the bat because the source files and the destination files are going going to be on the same file system. Maybe a little bit easier when we have different hosts. But as I'm going to teach you shortly, there are ways around that where you can account for file name changes and directory path differences. Now, I used the term target and auxiliary quite a few times, but we haven't formally defined them yet. Actually, we have defined one. We've been using RMAN in target mode. Target, I like to look at it as the principal database, your main current working database to which you're attached. Well, in a data dupe situation, your second instance that's going to host the cloned database is referred to in Oracle nomenclature as the aux or auxiliary instance. Okay, so keep that in mind as we go on. Another point, because the two databases, the target and the aux, have separate DBIDs, this means that you can use recovery catalogs when you do database duplications, and at the end of the process, when you have the two databases finished and online and ready to rock, they can both be registered in the same recovery catalog. There's not going to be any collisions because of that difference in DBID. Just by way of reminder, remember that we're not dealing with a standby situation, although we use the RMAN duplicate command for both of those situations. And finally, you can duplicate the full database or just some of it. You may not want the entire production database to give to your business analysts. You may have the data that the business analysts need contained within one or two table spaces. In that case, you would just format your RMAN command set to export or clone just selected table spaces and data files instead of the entire thing. The image we're both looking at right now is borrowed from the Oracle 11G Backup and Recovery Guide. If you don't have that book loaded on your e-reader or on your computer, please do that. It's just great. I'm the biggest fan ever of all the Oracle documentation. Those folks deserve huge kudos for how wonderful their documentation is. Anyway, what we're looking at here is the relationship between the RMAN client application and the two databases, the source host and the source database, the destination host, and the duplicate database. Now remember, we can host those databases and those instances on the same box. In fact, I'm going to do that scenario in the demo to show you how that works. But in this diagram, it shows two separate machines. And to look at the backup-based schema first, ignore this active piece in the middle. Pretend that's invisible. What we have is a backup taken, a full database backup plus archive logs from the source database, and we make those backup files, those backup sets, available to the destination host. This could be through standard file copy, it could be through a shared folder, whatever the mount point, whatever the case may be. In a backup-based database duplication scenario, the destination host has to be able to get to those RMAN backups. And where the destination host gets the backup data can come from a control file or the recovery catalog. Lots and lots of flexibility here, no question about it. And what happens with RMAN is, and where you're running RMAN is insignificant. As long as you have good, solid Oracle Net communications going on, you can run RMAN from your administrative workstation here. You make two separate kinds of connections. You make a target connection to the source host and an auxiliary connection to the destination host. And when the backup process happens, you wind up having two types of channels. Your traditional data access channels that we've seen before, and also on the destination host, we have one or more auxiliary channels that are responsible for integrating those backup file copies, or in the case of active database duplication, you're pulling image file copies on the fly from a running source host. You see how that works? So really, both processes, whether you're doing a backup-based duplication or an active duplication, they look pretty much the same. I mean, if you go into the Oracle documentation, there's some additional wrinkles to this picture where you might, well, not you might, you definitely can run a duplication without a target connection. You can do it with a recovery catalog, without a recovery catalog. There's lots of different permutations. I'm showing you the general truth of the process. So if we're looking at the active duplication, we're going to ignore the RMAN backups and pay particular attention to this pipeline here, orchestrated by aux channels between the source instance and the auxiliary instance. Now, if you're thinking to yourself, these two instances in this instance, if you don't mind the redundancy and wordplay, are communicating directly. Does this again mean we need Oracle Net communications between these two hosts? The answer is a resounding yes. In fact, in my experience doing this, and depending upon how good you are with Oracle Net, that can be the biggest stumbling block of all. Really, the rest of it is either just following recipe instructions, thinking to yourself, okay, how can I account for backups? How am I going to get the backup sets over to the destination host for a backup-based scenario? What am I going to do about the password file, the P file, all that? We'll get to that in just a minute, actually. But as far as the listener and the naming, the TNS naming, those tend to hang you up quite a bit. So we're going to make sure to cover that pretty thoroughly in our upcoming demo. Now, before we do that demo, let's look at the basic steps. I've tried to distill the process as generically as possible, and this applies to either the backup-based duplication or the active database duplication. We've got step one, prepare the environment. Select which method we're going to use. Are we going to do backup-based or are we going to do active? How are we going to account for file naming? Now, the reason why I have platform here is that according to Oracle documentation, the source and destination hosts need to be on the same platform. And what they mean there is the same operating system platform. In other words, if we're on 64-bit Linux on our source machine, in order to do a clone, we also have to have 64-bit Linux running on the clone side, okay? And the file naming means, is your directory structure on your source database different from on your destination? You may want them to be different, you may want them to be the same. We have to account for that. Especially this becomes important if we're doing a duplication on the same host. If we don't do something to change our file paths, then the process is going to fail right out of the gate, because how is Oracle going to lay down duplicate data files with the same names in the same directory paths as the source? It's just not going to happen. And you can actually customize the file naming in two spots. You can put it in your temporary P file, or you could do it in the RMAN block when you actually fire up RMAN and run the duplicate command itself. So other things that we need to do in the preparation are, as I said, set up naming, Oracle Net naming. Make sure that we have a listener configured such that both hosts can connect to each other. And of course, the listener is just the communications endpoint. Our tnsnames.ora file contains the actual service names. We need to configure that on each box and make sure that the boxes can resolve each other's database name. The P file, or the parameter file, we're going to create one, a temporary one, that'll be used on the auxiliary side such that when we start it up, it actually knows where stuff is. It's going to potentially store some of our rules regarding file naming. It's going to, as you know, give us the location of where our auxiliary control files are located. And most importantly, this P file is going to tell the aux instance what the database name is, the Oracle SID. Password file is something else we're going to need to make sure. We can either create it from scratch using the Oracle password utility or a PWD, or in the upcoming demo, I'm just going to copy and paste the existing one and rename it. Now, the middle step here between preparation, which really is the most time-consuming step by far, we simply fire up the auxiliary database in no-mount mode in preparation for a restore, and then in step 3, we fire up RMAN and run the duplicate command. Now, what we're going to see that's interesting about firing up RMAN is that we're going to make a dual connection. Remember earlier in the training, we made a dual connection to a target as well as our recovery catalog? Well, here we're going to make a target connection to our primary that hosts the production database, and we're going to also do an auxiliary connection to our secondary, or our aux database. If we were using the recovery catalog, that would be yet a third connection string going into RMAN. Now, as far as this goes, as far as setup for the demo, what we're looking at, in a two-host scenario, you'd wind up having on your primary machine, your source machine, the Oracle instance as well as your database up and running. That is just common sense, right? This is our production side of the equation. On your secondary machine that's going to host the cloned instance, the idea is you have the Oracle binaries installed. You do have to have an instance installed on the file system, but of course you're not going to have a database, because the point is at the end of the cloning process we will have populated the database files, and we'll also need to do some additional stuff besides just the data files, in particular create the service and Windows, etc. But I get ahead of myself. Let's get into the demo and step into this one step at a time. In this demonstration we're going to use active database duplication, and the wrinkle here is that we're going to stay on a single host. However, all the steps that you're going to see me do here are applicable to a dual host scenario. Moreover, I will spotlight any other minor differences between Windows and Linux-based installations. Primarily that just deals with file paths and a couple minor differences in directory path names. Now then, what we've got going on this machine called OraNugget is an installation of Oracle Database 11G, and I do in fact have a database with the Oracle SID of ORCL. That's the default one that Oracle gives you, so I haven't changed anything. Now, we need to think in terms of directory paths. Let me open up a Windows Explorer window, and I'll show you that my Oracle base directory is C Oracle. This is a fresh machine. It's got a different file path than what we've seen earlier in the course, and I'm using Oracle given terminology, the Oracle nomenclature for their directory paths. At least pretty much I am. We have up to DB Home 1. This is the Oracle Home, and then in there we have various subfolders. Let me step back one level, and we need to think in terms of what needs to exist on the auxiliary side of the equation. Think of things like data files. Normally we have data files stored under Oracle Base under Ora Data, and then we have a subfolder for each installed database. This is a vanilla installation of Oracle Database, and we have our control files, our redo log files, and our data files all in here. I'm going to create an auxiliary database instance with the very unimaginative name of dup test, because we're testing duplication. And in that folder is going to live our copied control files, data files, and online redo log files from the production side of the equation. Another path we might want to check out is under admin. I'll create a folder for my dup test database, and then in there I'm going to create a subfolder called adump. Now, we haven't talked about the automatic diagnostic repository yet. That's upcoming in a future nugget. I'm just pre-staging this on the auxiliary side. Other things we need to be concerned with are, especially in Windows, the service that's going to run for this instance. Let me open up a run prompt and type services.msc to open the service control manager in Windows. This would be a difference between Linux and Windows environments. We use the oradim command line utility to create a service. Normally we build a database using the database configuration assistant, and the DBCA tool will create the service for us. Here it is right here, Oracle Service ORCL. Now, in order to quickly and easily create a service for our dup test, what we can do is pop open an administrative command prompt and just run oradim new and then pass in the SID dup test. Simple as that. So after that service is created, it will show up in Service Control Manager. In fact, I shouldn't have closed Service Control Manager so quickly, and we can verify that the service is started for the second auxiliary instance. Let me scroll on down, and there's Oracle Service dup test. It looks like it started. We might want to change the startup type to automatic, but I'll leave it as manual right now. Next, let's consider the password file. This is particularly important when you have an auxiliary instance running on a separate server, because as you know, the password file contains the remote accounts that can embrace the sysdba privilege. The password file is stored in Oracle Home in a subfolder called, this is another minor difference between Windows and Linux, it's going to be Oracle Home Database on Windows, Oracle Home DBS on Linux and Mac OS X. And you can use Aura PWD to create your own password file. I'm actually going to just copy, because we're on the same server here, both the auxiliary and the primary databases are on the same box. I'm just going to duplicate this pwd.orcl.aura. I'm going to right drag and choose copy. And I'm going to change its name to reflect our auxiliary database. So it's going to be pwd-duptest.aura. Now, if you're working in Windows and you're not seeing these file extensions, you have to make sure to show your file extensions. In Windows Server 2008, Windows 7, you can type in the search box here, folder options, and that's going to give us a shortcut method of opening the folder options control panel item. And in there, we can navigate to the View tab and scroll about halfway down and make sure that you're showing hidden files. And in particular, we want to make sure we're not hiding extensions or operating system files. Just make darn sure that you're seeing all of those extensions. Alrighty then, so we've copied our password file. So far, so good. Before we get to the TNS configuration, let's address the issue of the parameter file. We're going to create a temporary called a dummy P file for the auxiliary instance. Now, the P file, as you know, goes under Oracle Home, Network, Admin. As you know, the SP file, or if you have a plain text P file, those are in the same directory as the password file. Oracle Home Database, Oracle Home DBS, as the case may be. And I just created one. You want to name the file init oraclecid.aura. So in my case, it's init duptest.aura. And this is just a plain text file that you can create with Notepad. Just want to make sure that you save it with the Aura extension. Now, when you try to open an Aura file in Windows, Windows doesn't understand that extension, so we can simply say, show me a list of programs, and open it in Notepad easily enough. Now, this is a sample file I've created. Let me expand the font a little bit, make it bigger so we can see it easier. The only parameter that's absolutely required in this temporary P file that will be used by the Oracle instance, the auxiliary instance I should say, is DB name. And the DB name is the short name for the auxiliary database, in my case duptest. And control files. We also want to put in our path to our control files, and as you know, we need at least two. Note that I'm using the path, the same path that we have on our primary instance, C Oracle Aura Data, and then the folder we created a couple minutes ago, and then I'm using just the default names for those control files, control 01 CTL, control 02 CTL. Now you can trick out those file paths however you want. All of the rules apply regarding multiplexing, as we talked about earlier. This is just a simple lab example though, so I'm intentionally keeping things simple. Other than those two lines, anything else you add here with regard to file name conversions and log file name conversions and memory parameters, all that kind of stuff is up to you. It depends on how robust you want this. We can either specify these naming conversion commands here in this temp file, this temp P file, or we can do it when we duplicate the database in our RMAN block. It's 6 in one, half dozen in the other. The reason why I like to add them here to the P file is because we can be really careful with our syntax and make sure everything is just so. And what we're seeing here is it's a pattern match. You can put a whole path in here, or you can just put a fragment. I'm saying, or I'm instructing Oracle such that when it sees a file name from an ORCL path, change that path to duptest. Same with the redo log files. Whenever it sees ORCL, change it to duptest. This is going to prevent collisions from occurring during the database duplication process. All right, so that's our starter P file, and that's definitely something that you'll want to spend time tweaking and getting just right. Now, what is for some the toughest part of the equation, getting TNS connectivity between the primary and the cloned instances. This is obviously tougher when you're working with two separate hosts. The thing to keep in mind, something that's not all that well documented, you need to set up the listener entries and the TNS names entries on both machines, on both the source and the auxiliary machine, not just one or the other. Remember, in an active database duplication, we have direct instance-to-instance communication. configuration. Now, how we create the listener and how we create the TNS Aura files is going to differ a little bit depending upon whether you want to go right into the files, which is my personal preference, or we can use some of the GUI tools that Oracle gives us. In the Start menu, for instance, we have in Configuration and Migration Tools the Net Configuration Assistant and Net Manager. Those can be launched from the Linux or Mac OS X or Windows command lines as netcfg or netca, respectively. The Net Configuration Assistant is kind of cool because it's a wizard interface that walks us through setting up things like listeners and service names, if it'll pop up, that is. By contrast, the other tool, Net Manager, just kind of lays everything out there for you in a workspace, and you're just kind of expected to know what's going on here in terms of setting up your listeners or your TNS files. I'm going to just exit out of here because, like I said, I prefer to work with the raw files. Your listener and your TNS names files are located under Oracle Home Network Admin on any operating system platform. Let's open up listener.aura first and take a look and see what we've got going on. Basically, my overall listener metadata involves TCP connectivity to my Aura Nugget host on port 1521. If we're dealing with two entries, one for this host and one for the auxiliary, we would just double it. Our specific SIDs attached to this listener, of course, map to our two databases, ORCL and dupe test, and as you see, the paths match for Oracle Home. Of course, the global DB name and the SID names are different in this case. Pretty straightforward configuration when you're on one machine. As far as our service names are concerned in tnsnames.aura, again, pretty darn straightforward, simply showing us the SID name along with the connectivity information, host name, protocol, and port number. Server type is dedicated in both cases, and the service names are nice and short and easy, ORCL and dupe test. Now, the best way to test connectivity, of course, assuming that you're on two separate machines, is to run a TNS ping to ensure that you are successful. You see OK. In this case, TNS ping dupe test. I'm OK on that as well, so I do have connectivity, no big surprise there. The next step in the process is to set up our dupe test auxiliary instance to prepare it for duplication. And as you know, because we did quite a bit on restores, that database needs to be in the no mount state. However, because we made all those changes to the listener, we need to bounce the listener service. So we need to do an ls nrctl. Now we could do a reload, but I'm actually going to do a stop and a start. ls nrctl start, and you can verify the listener what services it's configured to listen for in just a minute once the listeners come online by doing a ls nrctl services. That's a good troubleshooting tool for you to know. So we see that we have two services available, ORCL and dupe test. That's exactly what we want. So specifically, let's pop into SQL Plus. As the sys user, I'm going to put my unsecure password right on the command line because we trust each other, right? At dupe test as sysdba, we can't forget about that. Connected to an idle instance refers to the fact that we do not have a database set for dupe test yet, right? It's just an empty service. It's an empty collection of memory structures and processes, also known as an Oracle instance. Now, we can do nothing here right now. There's no data dictionary. There's nothing available. We pretty much have just startup no mount available to us, and I'm also going to force Oracle to use our custom P file that we created a little bit earlier. Let me go back and verify that path. I'm actually going to make things a little bit easier on me by getting the path up here, at least most of it, copying it to my clipboard, and we'll paste it in. We'll do startup no mount p file equals, and then we'll see how it goes. Try to paste it in. Boom, it worked. Good. And the name of that file was initdupetest.ora. So now if we select instance name from $instance, we see we sure enough are connected to the dupe test instance. So far so good. We're just about home, friends, just about home. Our next path, our next step I should say, we'll exit out of SQL Plus. I'll clear the screen, and we're going to make our dual connection in RMAN, where we're going to do a target connection to ORCL, and I'm again going to put my full credentials on the line here. Remember, we do not need the sysdba statement here because anything we do in RMAN presupposes the sysdba privilege. But check this out. Auxiliary, if I can spell that, equals sys, my password, at dupe test. And let's verify here. We know we're in RMAN in the correct mode if we get echoed back to us our target and auxiliary database names. All right, that's what we want to see. We're connected to the target database of ORCL, and there's our DBID. Connected to auxiliary database, we don't yet have a DBID because there's nothing mounted. So all we have left to do now is to issue the duplicate statement. And the kernel statement here, here's where you could do a whole bunch of different things. We could just issue the commands interactively here at the RMAN prompt. We can interactively do a run block, which is actually what I'm going to do. Or we could create a separate RMAN script file in the operating system and then just instruct RMAN to run that file. It's up to you on how you want to do it. In daily practice, I would use a script file every day and twice on Sunday. But in this demo, I'm just going to construct a run block, and here's what we've got going on. Duplicate target database, and target obviously is ORCL. 2, dup test. That's our auxiliary. Now, if we're not doing an active database transfer, if we're doing backup, then that's it as far as the duplicate command goes. If we're doing an active transfer, we would say from active database. I'm going to address the P file, and then if we were going to add our file conversion commands to the command line, we would do that here in our run block. Things like parameter value convert, log file name convert, log archive dest1, all that kind of stuff can be included here in our run block. I'm going to close with a semicolon, close the brace, and here we go. Let's get this done. Now, as you see here, we're allocating aux channels here. Depending upon your parallelism, I have a parallelism set for 2. It's going to execute this memory script here and just go through the process of shutting down, starting up, copying the files. And at the end of the process, I'm going to tuck this window off to the side. We're going to wind up with 2 databases, in this case on the same box. Thereafter, have no connection to each other, but we can hit the dup test database all day long and not affect the operations of our ORCL production database at all. Now, while that's cooking, I want to take you into Oracle Enterprise Manager to show you that we can do the same thing. That is to say, backup-based or active database transfers within a same host or between hosts. It doesn't matter. We can do all that from OEM as well. And as I've taught you several times, it's important to have both the GUI skills in OEM database control as well as the command line RMAN and SQL stuff under your belt. That's the way to be a well-rounded administrator. You never know what situation you'll find yourself in. And once we're in database control, we navigate to data movement, and under the move database file headings, we have a command called clone database. And now that we understand what's involved under the hood, you should understand every single one of these checkbox controls and radio button control sets that we see in the graphical surface. The first question here is asking us what schema or what type of clone we want. We can do an active, that's the default, or we can do a clone from an existing database backup. So we understand the implications there. Specifically with running database or active database transfer, we can use RMAN or just use a staging area. Well, we're going to leave the default here. We'll do an active copy with RMAN and we'll continue through the wizard. We're asked how many file copy processes we want to use, how many auxiliary channels we want to use. Now, I have a parallelism set of 2 here, and I'll leave that alone. If you've stored host credentials, that's obviously necessary because we're creating files in the file system. The next step, we're choosing our destination. We can choose the same or a different host. We can specify our Oracle home. Actually, we have to do that. Host credentials. This would be an administrative account, an OS administrator account on the target or auxiliary machine. And then we specify the global database name, an instance name for our copy. So I'll call this ORCL reporting. And for database storage, we haven't talked about ASM for a while. You can, in fact, clone from file system to ASM. I forgot the Oracle rule about the global name being 8 characters or fewer, so I'm just going to shorten it to Oracle_rep for reporting, because I'm going to presume that we want to clone this database for reporting purposes. And it didn't like the underscore either, so why don't we just try ORCL rep. I try to get creative, and this is what happens, right? It's asking us what we want to do in terms of directory structure. It's confirming that in this case, the clone database is going to be on the same host. We could let Oracle use its OFA, its directory structure. We can use the database area and flash recovery area based on what we've got going on down here. I'm going to leave the default setting here and we'll click next. So basically, we're getting abstracted from us a lot of that stuff. Actually, all the stuff that I showed you, the password file creation, the service creation, the TNS names and listener configuration. In fact, that's what we're doing on this step here. It's asking us where our net config files are located, where the listener Oracle home is. Do we want to have database control available for our auxiliary instance? Are we going to script anything to run afterwards? I'm going to answer no, just leave the default to all that stuff. Click next. And finally, we're asked to name the job, ORCL rep clone. I'm going to run this immediately, and there you go. We get a review screen that gives us really nice metadata here. We can look at our source database, exactly what's going on, the host, the database version, the instance name, whether it's running an archive log or not, and then we have what's going to happen at the end of this process. We're going to have a cloned database called Oracle Rep that has the same Oracle home as the source, except there'll be a subfolder in there called Oracle Rep, of course. And at this point, it's just a question of submitting the job. And by the way, this notion of the Oracle Scheduler is really, really awesome technology. For the purposes of you as a database administrator, it's going to give you great relief to be able to create jobs, get them perfected, and then run them on a regular basis. And for your exam success, actually, I don't know if you've looked ahead to future nuggets in this series, but we are going to be deep diving into the Oracle Scheduler. After the job has been successfully submitted, we can click OK to just continue our work and go on to other things, or we can click View Status and periodically refresh the resulting page. This is going to give us a blow-by-blow list down at the bottom as it completes each stage in this process. So it may take a while to complete. We can delete the run, we can edit it, or view its definition. I'm just going to pause the video while it does its magic. Alrighty then, that procedure succeeded. We can verify the steps down at the bottom here, and it's all stuff that we know about. Preparing the source, your password file, control file creation, creating the destination directories, building and copying initialization and password files, blah, blah, blah. We know about all this stuff already. So at this point on this server, we actually have 3 databases that we can connect to. ORCL, our duplicate auxiliary instance, and then now we have third Oracle Rep. Duplicating a database review. In this nugget, we started by understanding the why, or the business case for duplicating a database. I hope you're now fully apprised as to why this is an important skill to have as an Oracle database administrator. You're also now well acquainted with the technology behind duplicating or cloning a database. We know, for instance, that we have both the backup-based, which is kind of a legacy approach, as well as the active database duplication that was introduced in Oracle 11g and will likely be spotlighted on your OCP exam. You understand the relative advantages and disadvantages of each approach, and you know how to actually do it in Oracle, not only using the advanced tools, quote unquote, using SQL Plus and RMAN, but also at the end, I showed you that the same functionality exists in an easy wizard-based interface in Enterprise Manager. I hope that this has been informative for you, and I'd like to thank you for viewing.